Hey everybody, welcome back. We're starting inverse functions today, which is going to be awesome. And here's what inverse functions are. Well, before we do that, actually, let's go over our objectives. So today, students will be able to find inverse functions formally or informally and verify that two functions are inverses of each other. Use graphs of functions to decide if they'll have an inverse function, determine whether functions are one-to-one, and find inverse functions algebraically. So let's get started. So inverse functions, basically, the thing that you need to know about inverse is we're basically switching the value for x and y. Okay, so in essence, if you have a graph that looks like this, actually, if you have a graph that looks like this, where this is our f of x, the graph of its inverse is going to be the opposite. So it's going to be reflected across the line y equals x. So inverses are reflected across the line y equals x. So it's going to look like this. Okay. Okay, and the way we say it is the inverse of f of x, we say is f of inverse x, or the inverse of f of x. Okay, so this right here is our special notation for inverse. All right, let's kind of look at this graph, this diagram here. So if the domain of f is x, and we would normally input it into the range of f of x. What we're saying by switching these values is that the range of f then becomes the domain of the inverse of f. And then we put those domain values, which were the range of f, but are now the domain of f of x, or f, the inverse. And then we're going to put them into our function, which is the inverse right here. And our function of the inverse will be the same set of values as the range of, as the domain was for the f. So again, we're just switching the values of x and y, or switching the values of the domain and range. Okay? So when we're talking about the inverse of f of x, the domain is technically the range of f of x, and the range of the inverse is technically the domain of f of x. So let's go ahead and just kind of do one informally here. Okay, and here's what that means. When we are looking for an inverse, our values switch. Another thing that we can say verbally is that the inverse of f of x undoes f of x. Okay, so here's what they're opposites of each other. They undo each other. So if f of x equals 4x, what would be the thing that undoes 4x? How could we undo the 4 on the x? Well, I know the thing that undoes it, instead of multiplying the 4, we could divide by 4. So the inverse of f of x we could write as x over 4 instead. Okay? And then there's one more thing you need to know. If f of x is the inverse of f of x and vice versa, f of the inverse of f of x equals x, and the inverse of f of x also equals x. Okay, so we're going to come back to that. But that's technically the definition of the inverse, is that the composite functions of f of x and the inverse of f of x will both equal x. Oh, and they actually said it right here. So this is the official way with all the mathematical terminology, which isn't really important for us to read, actually. We have to be able to make sense of it when we read these. So here's the definition. If f and g are two functions such that the composition of f of g of x is x and g of f of x is x, then we know that they're inverses of each other. We can also say that the function g can be denoted by f inverse of x. So we know f of the inverse of x is x, and the inverse of f of x is also x. Okay? The domain of f is equal to the range of the inverse, and the range of f is equal to the domain of the inverse, which is what we've just been talking about. So let's go ahead and verify these algebraically. Remember, verifying this would mean f of the inverse of x would equal x, and the inverse of the f of x would also equal x. So let's apply that to what we're looking at here. F of x is 2x cubed minus 1, and g of x is the third root of x plus 1 over 2. We need to see that they're inverses of each other. So if this is f of x and this is g of x, we'll have to say, if they're inverses of each other, then f of g of x will equal x, and g of f of x will also equal x. So we're going to check these both. So let's try it. Ready? We're going to stick these inside. So if this is f of x, this is the outside function. So f is really 2x, which I'm going to put a parentheses here, cubed minus 1. And to plug that in, I'm going to take the g of x and stick it right in here. So we get the third root of x plus 1 over 2. And let's simplify. So I'm going to do the inside of the parentheses first, which is right here. I know that this cubed and this cubed root are going to cancel each other out. So I'm left with 2 times x plus 1 over 2, all minus 1. Now I know this 2 and this 2 here, because 2 times x plus 1 over 2, they're going to cancel out to 1. So I'm left with x plus 1 minus 1. And we know x plus 1 minus 1 is just x. So in this case, it works. Okay? But we have to do both sides. We have to make sure that both composite functions work. So let's go ahead. So now we're going to start with the g function because that's what's outside. So here's g, which we're going to write it with, every time I see x, there's a space. So here's the third root of x plus 1 over 2. And now we're going to insert that f of x into that value here instead of the x value. So we say 2x cubed minus 1. Now we just have to solve it and see if it equals to x. So a couple of things that we're going to do first. This here is our parentheses, but there's nothing we can do with it. So now our next parentheses is this. Anytime there's a numerator of a root, that's basically a parentheses. So what's 2x cubed minus 1 plus 1? Well, it's just 2x cubed. So remember, that's inside the third root, and it's over 2. Well, inside that root, again, it's got its own parentheses, so these 2's will cancel. And we're left with third root of x cubed. Well, I know the third root and cubed are opposites of each other. They undo each other's process. So again, it's x. And so now we know that indeed f of x and g of x are inverses. Okay. We kind of briefly talked earlier about the graph of the inverse function. This is a really good visual that if this gray function is f of x, and this is the line y equals x, which is the line that the inverse has to reflect around, that the inverse would be the exact opposite of it, and it reflects right across that line. So let's see, okay, how can we tell even if an inverse exists? One of the ways to tell if they exist is, number one, we have to know what's called a one-to-one function. To have an inverse function, a function must be one-to-one, which means that no two elements in the domain of f correspond to the same element in the range of f. So one value of x goes to only one value of y and vice versa, okay? So a function of f is one-to-one when a and b in its domain, f of a equals the f of b, implies that it's the same value, okay? So one value of the x goes to only one value of y. And if we can determine if it's one-to-one, then we can say that f has an inverse function, f inverse. Okay. The other thing we know is we can use what's called the horizontal line test if it's graphed. And the horizontal line test basically, go ahead and ignore this. The horizontal line test basically tests if things are one-to-one, okay? The horizontal line tests, if it passes, if that means it's either increasing or decreasing the entire domain. So if it passes the horizontal line test, then it's one-to-one. Okay, and here's what that means. Let's say you've got this function here. The horizontal line test is very similar to the vertical line test in that you literally graph one horizontal line, and if it only hits one time, it passes. Okay, and we can do this anywhere on the graph. If it only hits one time, it passes, which means it tells me that this function is one-to-one and that it has an inverse. Let me show you one that wouldn't pass the horizontal line test. So if I had a function like this, like our parabola that we've been working with, if I did the horizontal line test, it hits twice, which means it does not pass. So it's not one-to-one, and it does not have a function. So in order for it to be one-to-one, or in order for us to determine if it has a inverse, it has to pass the horizontal line test. Okay. Now we're going to talk about finding functions algebraically, which actually is not too scary. People are afraid of it at first, but it's not too scary. So the first step in the inverse functions is that we're going to switch the values of x and y. Step 2, you're going to solve for y. And step 3, you're going to replace the y with the notation f inverse of x. So really, it's as easy as 1, 2, 3. Really, I promise. Okay? So let's use that process, and we're going to do this one first. It says find an inverse function algebraically. So remember, again, our first step was switch the values of x and y. And I know you're thinking, Mrs. Elzerulo, there's nothing that says a y here. Well, remember that f of x is really the fancy way of saying y. So here's our y. And now we're going to do this step. We're going to switch. Whenever I see y, it becomes an x. Whenever I see x, it's going to become a y. Okay, so there's step 1 done. Step 2, remember what it says? Solve for y. That basically just means to get y by itself. So here's the y, and I need to get it by itself. So first thing I'm going to do is remember that when we're getting something isolated, we have to do the farthest thing away from it first, as long as it's on the same side of the equal sign. So this 2 is the furthest thing away from it. So if it's being divided by 2, I'm going to multiply the entire function by 2. Whenever I do on one side, I have to do to the other side. And this cancels with this. So now I'm left with 2x equals 5 minus 3y. I'm still getting y by itself. So I'm going to subtract 5 over to this side. We're left with negative 3y equals 2x minus 5. Then the last thing we're going to do to get y by itself is we're going to divide both sides by negative 3. So we're left with y equals 2x minus 5 all over 3. Or you could write this as negative 2/3 x plus 5/3 equals y. So there was our step, getting y by itself. And then our last step is replace the y with f of inverse of x notation. So we know negative 2/3 x plus 5/3 equals the inverse function of x. And that's it.